Hello there, Mr. Sutton here. I've got the IM3 Honors 4-2 Part 2 homework solutions on completing the square. For this problem, it looks mighty tempting to try to factor this, and we can try. Two numbers that multiply to 9 and add up to 8. So this is actually a little bit tough. If it were numbers that multiply to 8 and added up to 9, we could use 8 and 1. Unfortunately, the only options for multiplying to 9 are 1 and 9 or 3 and 3, and none of that's going to add up to 8. So we're going to have to go with another method like completing the square on this one. To complete the square, we're going to start by clearing out this constant of 9, subtracting it to the other side. And now we're going to take half of my x term, half of 8, which is 4, and then square that and add it to both sides. So I'm adding 4 squared on the left side and the right side. On the left side now, I've actually completed the square. This is a perfect square trinomial. So I can factor this into x plus 4 squared on the left side. And on the right side, we've got negative 9 plus essentially 16, which is going to give me 7. At this point, I just need to square root both sides. So that's going to give me x plus 4 on the left. And on the right, I'm going to have plus or minus square root of 7. I don't know what the square root of 7 is. It's not a rational number, so we can just leave it in radical form. But to get x by itself, I still have to subtract the 4. So my final answer then will be negative 4 plus or minus radical 7. For number 3, we're trying to solve for x. Now this one, you actually could factor it. So if you were looking to do this as quickly as possible, that would be your best bet. But let's get some practice completing the square because this is the completing the square homework. So let's start by adding 21 to the other side to clear out that constant. And next, I need to add something to the left side that completes the square, gives us a perfect square trinomial. So we take half of that x coefficient, so half of 4 is 2, and we're going to square that and add that to both sides. Next, now that I've completed the square on the left side, I'm going to factor that into a squared binomial. So that'll be x plus 2, the whole thing squared, and then we'll have 21 plus 4 on the right side, so that's 25. Now we've got a perfect square on the left. Let's go ahead and square root everything. So we got x plus 2 equals plus or minus 5 if we square root that 25. Subtract the 2 to get x by itself. And we can combine these, so we will. Negative 2 plus 5 is 3. Negative 2 minus 5 is negative 7. Let's go ahead and try to solve number 4 now. This is one that looks like, maybe I could try factoring that, but honestly, it's going to be faster if I just complete the square on this thing. So let's move that 120 over to the other side so that I have a fresh slate to start with here. What am I going to add to the left side to complete the square? Well, half of 2 is 1, so I'm going to add 1 squared to both sides. Which is kind of silly because it's still just 1, but again, it's easier for me to visualize my next step if I write this thing inside a square. All right, so my left side, I'm factoring that. That's going to be x plus 1 squared, the whole thing squared, and we'll have 121 on the right side. And then next, let's square root both sides. So we've got x plus 1 equals plus or minus, well, that's going to be 11. And then if I subtract the 1, I've got negative 1 plus 11, which is 10, and negative 1 minus 11, which is negative 12. So it turns out it was factorable. If you get rational numbers in an answer, you could have factored it. X minus 10, x plus 12. But who's keeping track? We got our answer. For number 5, we're trying to solve for x on this one. I'm not sure if this is factorable or not. I can definitely factor a 5 out of all these. I'll have a 6 and a 13. That's probably not going to work out. So let's complete the square on this. Let me move that 65 over to the right to clear out some space. And then I don't like this 5 here either, so let's divide everything by 5 so I just have x squared. And then we'll have also, in addition to the x squared, we'll have plus 6x equals negative 13. I'm going to complete the square now. So I take half of that x coefficient, so 3 out of the 6 here. So we got 3. I'm going to square that. I'm going to add that to both sides.
Next, I can factor the left side into that squared binomial. We'll have x plus 3, the whole thing squared. And on the right side, this is negative 13 plus 9, which is negative 4. We are now ready to square root both sides. So that'll be x plus 3 on the left side. And this is going to be plus or minus square root of negative 4, which is really just plus or minus 2i. Subtract the 3. So negative 3 plus or minus 2i is our final answer on this. For number 6, we're trying to solve for x in this equation. Now, maybe this one is factorable with the AC method, maybe not. I'm just going to go to complete the square and not worry about it. So let's add the 2 to the other side. Divide everything by the coefficient of x squared. So we've got x squared minus 4/3 x equals 2/3. And then to complete the square, I need half of that x coefficient. So remember, you either double the denominator or take half the numerator to cut a fraction in half. In this case, it's easier for me to just take half the numerator. So we'll have negative 2 over 3. And then we'll have to square that and add that to both sides. So negative 2/3 squared to the left side and to the right side. Time to factor now. Left side, we're going to have x minus 2/3, the whole thing squared. On the right side, we've got 2/3 plus 4/9. And I'm going to simplify the right side now. I need a common denominator for that. 9 would be a good one to use. So then I can just multiply this fraction on the left by 3 over 3. So that'd be 6/9. Add that to the 4/9 already there. We got a grand total of 10/9. And now we're ready to square root both sides. So we have x minus 2/3 with no square equals plus or minus square root of 10 over 9. So that's the square root of 10 over 3. And to get x by itself, I'm just going to add 2/3 to the other side. Because I have a common denominator, I can actually just move 2 into the numerator with the plus or minus 10. So that'll be 2 plus or minus the square root of 10 all over 3.